Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. Welcome to question 2 part A, January 2012 CSEC math exam video solutions. Now, question 2 part A gives us a pair of simultaneous equations to solve. These are the simultaneous equations. And if we observe, we have a plus 2y here and a minus 2y in this second equation. So realize we can eliminate y from these two equations if we simply add them. Right? So let's go ahead and do that. Equation 1 and 2, and we're going to add those two equations so we can eliminate y from the two equations. Now when we add the two equations, we are basically adding this side, and we are adding these two on this side. And when we add these on this side, we end up with 3x plus x, which is 4x. These eliminate each other, and then 13 minus 1 is 12. So the result of adding those two equations is 4x on this side and 12 on this side. Right? The y values are eliminated. And simply, if we divide both sides of this now by 4 to make x the subject, we realize that x is 3, or simply 4 multiplied by 3 is 12. So x must be 3. And that's the result. We now need to find the corresponding y value. And to find the corresponding y value, we can substitute in either equation 1 or 2. Let's say we substitute in equation 1. If we substitute x equals 3 in equation 1, we are simply substituting 3 here, right? And you end up with 3 multiplied by 3. When you substitute 3 for x here, you get 3 multiplied by 3 plus 2y, that's a plus 2y, equals 13. And we simply need now to solve this for y, right? So going through the steps, 3 multiplied by 3 is 9 plus 2y equals 13. That's what we have. And then we need to subtract the 9 from both sides, or we say we take the 9 on this side and change the sign to negative, and then we'll divide by the 2. So the result of y is that we subtract the 9 from both sides, or we take the 9 over on this side and change the sign, and then we divide by the 2. So theoretically, we have subtracted 9 from both sides to get 13 minus 9, and then we have divided both sides by 2. But the quick way of doing that is to say you take the 9 on this side, change the sign to minus, and then or divide by the 2 on this side. So this is the result. And 13 minus 9 is 4, so that's 4 divided by 2. The result is 2. So y is 2. 4 divided by 2 is 2. And so we can write our solution line. X equals 3 from here, and y equals 2 from here. And that's a solution for that pair of simultaneous equations. Let's now look at question 2b. Now question 2b is asking us to factorize completely, and there are two parts. Part 1 is x squared minus 16. X squared minus 16. Now this is the difference of two squares. Initially it does not look like the difference of two squares, but 16 is a perfect square of 4. So we need to first write it as the difference of two squares, right? And that can be expressed as x squared minus 4 squared. And then when we apply the rule of the difference of two squares, we see the result is x minus 4 multiplied by x plus 4, right? And that's the answer for part 1 of question 2b. Now part 2 is giving us this to factorize. Now I see 4 terms there. So I know we are dealing with a factorization by parts. So what we're going to do, we're going to look for a common factor in the first 2 terms, and then look for a common factor in the second 2 terms. But we have to factorize it in such a way that we end up with common factors on both sides. after we do the first line of factorization. Now in the first two, the common factor is simply x, right? And when we factorize x out of these two terms, we end up with that. But a good tip is to place what's in the bracket here over on this side. We want this to end up in the factorization of this side, so we'll put that in first. And then if we had factorized the 8x and have a 2x here, the factor must have been a plus 4, right? It must have been a plus 4 because 4 multiplied by 2x would have given us back our 8x. So we must have factorized a plus 4 out on this side. So let's put that in and then check the factorization, right? So this plus 4 multiplied by the 2x is 8x, and then this plus 4 multiplied by minus 3 is minus 12. So we know that we have factorized this side correctly, and we have ensured that we have the same thing in both brackets, right? And so now this is just like saying x apples plus 4 apples, and the result therefore is going to be x plus 4 apples, right? So the final line of factorization is this: x plus 4 in the first bracket multiplied by 2x minus 3 in the second bracket, and that's the result of that factorization. All right, let's now look at question 2c. Now question 2c tells us of tickets to a football match, and that adult tickets are sold for $30 each and children tickets are sold for $15 each, right? And it says that 28 of the tickets are bought by a company, right? And X of the tickets are bought for adults. So the number of adult tickets bought of the 28 is X, all right? Now the first part is asking us for the number of children tickets. And if there are 28 tickets in total and X of the tickets are for adults, then the number of children tickets must be 28 minus X, right? Number of children tickets must be 28 minus X. We are now asked to find the amount spent for adult tickets. Now, if there are X adult tickets at $30 each, then the amount spent for adult tickets must be 30 multiplied by X dollars, right? So that's it, $30 each, and there are X of them, so the amount spent for the adult tickets must be 30X. And then we are being asked for the amount spent for the children tickets. The amount spent for the children tickets must be $15 for each multiplied by the number of children tickets, which is 28 minus X. So that's $15 multiplied by this 28 minus X, and that will be the amount spent for the children tickets. And then if we expand, we end up with 420 minus 15X dollars. That's the amount spent for the children tickets. We simply multiply 15 by 28 and then 15 by this negative X, and that's the amount spent for the children tickets. Now part 2 is asking us to show the total amount spent on the 28 tickets. So the total amount spent on the 28 tickets is the amount spent on the adult tickets plus the amount spent on the children tickets, right? So that's it. The amount spent on the adult tickets is 30X, and the amount spent on the children tickets is 420 minus 15X dollars. So we're adding these two. Now this 30X dollars minus this 15X dollars will be equal to 15X dollars. So it's going to be 420 plus 15X dollars. Alright, and that's the result. The 30X minus this 15X gives us this 15X plus this 420. So that's the amount spent on all 28 tickets. Now part 3 tells us that the total spent for the 28 tickets is $660, and this is the expression for the total amount spent for the 28 tickets. So it means that this expression here is equal to the $660. And from that we can calculate X, which is the number of adult tickets, which is what part 3 is asking us to find, the number of adult tickets. Alright, so we need to equate this expression to 660 so we can calculate X, and that's it. So we need now to just solve this equation for X, and the number of adult tickets, which is X, is therefore given by 660 minus 420 divided by 15. Take the 420 on this side and subtract it, and then divide by the 15. Comes under here. So it's 660 minus 420 divided by the 15. Subtract the 420 first and then divide the 15. That's how we end up with this expression. And when we calculate the numerator and then divide by the 15, we end up with 16. The result is 16. So the number of adult tickets, which is X, is equal to 16. And that's the solution for question 2. And we will do question 3 in another video. Alright, see you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.